In this video, we'll talk about solar controllers, how the overall system ties together, and a few small items that you definitely don't want to forget. Welcome to the final installment of our Design Your Own RV Solar Systems series. We just went over different types of solar panels and mounting. Now we need to choose an appropriate solar controller to translate what's coming down from your solar panels to what your batteries need. There are two kinds of solar controllers: pulse width modulation, or PWM, and maximum power point tracking, or MPPT. MPPT solar controllers are newer technology, a little more expensive but also more efficient. The efficiency here is actually a pretty big deal, which is why I'd almost always recommend MPPT controllers. Depending on conditions, we're talking between 5 and 20% more efficiency. If you do the math, you'll see that PWM controllers really aren't worthwhile at all unless you are building a fairly small setup. If we are talking a small setup, a PWM controller might be in the $20 to $30 range, while a roughly equivalent MPPT controller might be more like $80 or $90. That's not a drastic cost difference in the overall scheme of things, and with the difference in efficiency, your solar setup doesn't have to be real big before the type of solar controller you're using makes a big difference. You lose some efficiency when you connect two circuits together that don't really match. If you're familiar with speakers and amplifiers, you'll know what I mean. You want to make sure that your amp has the same impedance as your speaker. If they're the same, you get maximum power transfer between them. And it's similar with solar panels and solar controllers. MPPT controllers have sensing circuits built into them that can track with your solar array as the impedance changes with solar conditions and different temperatures. PWM controllers, on the other hand, are fixed, and that's why MPPT controllers are usually more efficient. Although this really doesn't hold true with really low power arrays. PWM controllers are probably the way to go if your total solar wattage is under 200 watts. Once again, I recommend choosing a known brand when you buy a solar controller. You're also really going to need to dig into the spec sheets for these when you find one you like. Pay attention to the maximum input voltage. For example, let's say you have some larger solar panels that operate at up to 33 volts, and your solar controller's maximum input voltage is, let's say, 80 volts. You'll know right off the bat that you can't wire more than 2 of those panels in series to that controller. Also, pay attention to how much total wattage they can handle. The solar controllers I'm using can handle a whopping 5,800 watts of solar each, if they're charging a 48 volt battery bank. Since I'm using a 12 volt system, they're actually only good for 1,400 watts each. Since I have just over 2,600 watts of panels on our roof, I definitely needed more than one, and I actually ended up going with 3 of them, so I'd have some room to expand and so they don't get quite as hot, which is definitely overkill. So this is yet another instance of where you'll get to play the game of what can I get the best deal on and still have all my specs match up. Fewer solar controllers isn't necessarily better either. If you have 8 panels and you've found an amazing deal on a quality solar controller that can only handle 2 of those panels, 4 controllers isn't necessarily a bad thing. Of course, you will have to run more wiring for all of that. The specs on your solar controller might also play into what combination of series and/or parallel wiring you decide to go with for your solar panels. As a quick recap, solar panels wired in series will add their voltages together. When they're wired in parallel, you'll add their current together. My 175 watt panels operate at a max of about 20 volts and about 9 amps. I'm just rounding up here for simplicity. So 2 of these in series would give you 9 amps at 40 volts. 2 panels in series wired in parallel to another 2 panels in series would give you 18 amps at 40 volts. If you just wired all 4 panels in series together, you would have 9 amps at 80 volts. In ideal conditions, that higher voltage with lower current would probably be the most efficient way to wire these 4 panels. The problem here is that you also want your system to have some tolerance for being partially shaded as well. If 1 or 2 of those panels has a shadow cast across it, it's going to drag down all the other panels that are wired in series with it. So if you're parked somewhere that's pretty clear, but let's say by early afternoon, there's one tree that happens to cast a shadow across the back end of your RV, the other panels that are wired in series with that shaded section will have to overcome the added resistance of the panel that isn't helping out as much anymore. This is why it's best to split up your panels into a series parallel configuration. If you had these 4 panels with 2 in series and the other 2 in parallel with it, and a shadow is cast across 1 or 2 panels on one end, the other 2 panels that are in parallel with the shaded panels will be unaffected and still bring in power. There are a lot of questions out there on forums and social media groups about series parallel wiring. People always want to know what the best way to wire up their panels is, and I really think that the answer to this question is that there really is no best way. Think of it just as solving a puzzle with multiple ways to get the right answer. Do you have a lot of panels? Split them up into equal groups where the ones in series are next to each other. That'll give you some tolerance for these partial shade conditions. Next, make sure that your groups of panels are feeding power to your solar controller or multiple controllers within the specs for each controller. That's pretty much it. It's really not worth overthinking it past that. At this point, we're actually getting kind of close to the end of designing a solar system, but there still are a few more odds and ends that are actually really important, and you don't want to forget them. First, let's talk about fuses again. Each inverter and solar controller need fuses in line with where they connect to your batteries. This is really just a basic safety thing. If something were to go really wrong with one of these devices, a properly sized fuse is what's going to stop it from starting a fire. All of these devices should have info on the proper fuse size and location in the manual or install guide. Solar panels should also have fuses in each string of panels that are wired in series. The spec sheet for our 175 watt panel says they have a maximum fuse rating of 15 amps. So each set of our panels that are in series have a 15 amp fuse. Another really important item that is sometimes overlooked is a battery kill switch. These are big, beefy switches that are made to handle a huge amount of current. The one in our setup is actually rated for 600 amps. Not only is it an easy way to disconnect your battery bank and shut off 12-volt power when you need to, but it's also another safety item. If there's an electrical problem, you want to be able to shut things down fast and not have to try to dig out a wrench and start disconnecting batteries. Make sure you double and triple check all of your wire sizes too. You should know what the max current is going to be from your solar panels and choose a wire gauge that can handle a bit more than that. You might have smaller wires going to each of your batteries from a bus bar, but a 3000 watt inverter on a 12 volt system can pull at least 250 amps, and you're probably going to want the biggest wire that you can possibly get for that, which is usually quad-aught. Also, for those sections with really big current like that, it helps to keep those wires as short as possible. Next, do you have a motorhome or a van? If so, you might want to check if your house batteries are connected in any way to the battery for your motor. There should at least be an isolator that keeps your house battery separate from your automotive battery or batteries. I'm in a fifth wheel, so this really wasn't something I had to deal with. It is, however, worth mentioning that you can have a DC to DC charger that allows the alternator from your engine to actually charge your house batteries when your engine is running. An isolator sort of works like a one-way valve that allows charge to flow to your house batteries from your alternator, but it otherwise keeps the two systems separated electrically. Especially in the small RV or van world, this is a really nice way to get away with a smaller solar setup due to maybe a lack of roof space. Since a van or a small RV is often not just your living quarters, but it's usually also your transportation, it's helpful to be able to recharge your house batteries when you're driving around. One last thing I'd like to mention while we're talking about things that you shouldn't forget: an infrared thermometer is super helpful. You can use it to see how hot your solar panels are getting, and as you go into testing your completed setup, you can use this to check to see how your inverter or your solar controllers are doing and if they're getting too hot. You can also use it to check some of those high current wire connections that would otherwise maybe burn your hand. I actually had a fuse holder that was getting super hot, and this thing saved me from burning my hand pretty bad on it. It turned out that the original fuse holders that I had for my inverters couldn't actually handle the amount of current that was going through them, even though the manufacturer claimed that they could. So definitely size up your components to more than the minimums of what's required. This also leads us into why it is so important to spend time testing your completed setup. Just like you would probably want to go on a couple of shakedown trips with a new RV to make sure everything works right, I would spend at least an afternoon monitoring everything when it's complete. Use your thermometer to make sure nothing's getting too hot. Once everything looks good, you should definitely load test your inverter. This will be pretty easy if you have a smaller setup. Just plug in whatever you plan to run and let it go for a while, and then watch to see that nothing gets too hot. For a bigger inverter, start halfway or so and then build up. To test my 3000 watt inverters, I started with a bowl of water in the microwave and ran it for a few minutes. That's a 1500 watt load. Running a 1200 watt AC unit along with a 1500 watt water heater for 20 minutes was how I discovered that issue with the fuse holder. Test everything until it is good and boring. You really don't want anything exciting happening with a power system. The next step is to go out into the wild with it. Once you've moved everything down the road, it really doesn't hurt to go through and just make sure that all of your connections are still nice and tight. The first night should be pretty smooth since you'll be showing up at your destination with full batteries. You'll start to really get to know how it all works together over the next couple of days as you see what it looks like during peak sunlight hours and then how that power actually tapers off in the late afternoon. I'd also say don't expect to see your maximum rated wattage during those peak hours. Solar panels get their ratings in a lab at a specific temperature, and the real world just has a lot more variables. Hopefully this series has given you some helpful information. Again, I am not a professional. This is based off of my experience designing and installing our system. If there's any part of this that you're not confident in doing yourself, take it to a professional. Also, don't be afraid to start small, but definitely have a plan in mind for your end goal so you can buy it in parts. We actually waited a couple of months after installing our batteries and inverters before adding the solar panels. As always, feel free to ask questions in the comments. Thanks for watching, and we'll see you all on the next adventure.